Sorry for the small delay. Welcome everyone. My name is Wim. I'm 28 years old. I study computer science at University of Technology in Delft. And I'm also a lead developer at Weave. I'll talk briefly about Weave. So how do we develop our software? Well, obviously we use Go. We deploy our apps on Kubernetes with Istio. And we build our front end with web components based on lit element. And we write those in TypeScript, and we use other techniques like Redux and Sagas. Some of our projects, for example, we have Juve, which is a car sharing platform. We also have Energy Zero, which is a platform for energy suppliers, which try to disrupt the energy market. Myself, I'm working on a new root CA, which should be the European alternative to Let's Encrypt. So, what will I be talking about today? First of all, I'll be covering unit testing in general. Afterwards, I'll talk briefly about the basics of Testify. Then we're going to talk about mocking. And with mocking, we are going to look at some advanced testing examples in Go. And I'll finish by telling how we can analyze our tests. Alright, so unit testing. What is it? Well, unit testing is assuring that parts of our system behave in a certain way by executing it automatically. And why should we do that? Well, when we have unit tests for parts of our system, as long as those tests keep running, we assure that those parts of our system still behave in the same way as we defined in our test cases. It's also very convenient when you have to refactor a part of your system, such that you still know that some parts of your system are still working as you defined in your test cases. So obviously we'll be talking about Go tonight. So what are our units in Go? Well, I consider the functions of Go to be our units. And then the question would be, what do we need to test? And in my opinion, we should at least test the exported functions of packages. And for example, functions which serve as controllers for example, your API or gRPC routes. So, we're going to take a look at quite some code tonight. So I hope everyone is able to read Go. Alright, so I wrote a simple package which gives a few implementations of a Fibonacci function. So for those of you who don't know Fibonacci series, the next number will be the addition of the previous two numbers. So I created 4 different implementations, recursive one, an iteration, and 2 dynamic programming solutions. But we want to assure that all of these functions return a correct result. So for that, we define a test case, and we test those with Testify, which is a open source library on GitHub. And to run those, and in Testify we use Testify suites. So to run such a suite, we define a normal native Golang test function, which receives a testing.t parameter, and on the Testify suite package, we call the run function on our defined test suite. So this is how the suite looks like. So it extends the Testify suite. And I also give it a parameter cases, which is an array of structs with a testing name, some input, and an expected output. So what's really cool about this test suite is that it has a setup test and a teardown test. So for every test case you define on your suite, first the setup test is run, and afterwards the teardown test is run. So what we can do in our setup test, we can set up some test cases. So for Fibonacci, for example, for 1 we expect 1, and for 20 we expect more than 6,000. So afterwards, when we defined those test cases, we can keep our actual test cases really clean. Because we defined a type for our Fibonacci function, which receives an integer, returns an integer, we can simply run those by passing the function into a run fib cases function, which are then run as subtests, and we give an input of the test case into the function, and we verify that the output is actual output we expect in our test case. So that's actually all there is to the basics of the Testify suite. One thing I think is really convenient to add to this is we like to add some form of base test suite. So for example, we have an application with 20 microservices, which are all gRPC services, and all of those services expect some given context to be set up before those functions can actually be executed. So what that would mean is that you have to do that setup test in every gRPC service. But what you can also do is define a base suite, and here I just created a very simple one, which sets a time button now when it starts and prints the amount of time it took to run the suite. But you can also use this to set up more complicated stuff, and then in your actual test you can extend this test suite when you're running, for example, your gRPC service tests. Alright. So, those were the basics. So this is where it becomes a little more complicated. So we're going to talk about mocking. What is mocking? Well, the definition which I derived here is from Wikipedia, but I actually really liked it. So it states, mock objects are simulated objects that mimic the behavior of real objects in a controlled way. So that's actually what it does, right? So we have some package, for example, which I'm going to illustrate as well, an email client, and that package is used, for example, in our API, but we don't actually want to send emails when we are executing our tests. However, we do want to test the functions which call that email client. So we want to do the actual call to that package, but control the way it behaves instead of sending a real email. So when do we want to use this? So for example, when we are calling external APIs, when we do internal service calls, maybe when you read and write to a disk. But you can also do that more general whenever you're going outside of your own application, your function. So we're going to take a look at some examples. Before we go to take a look at that example, I want to ask you guys, I defined here an email wrong package, which returns a client, and I want to know from you what is wrong with this package, except from the fact that there isn't an actual implementation of the send mail function. I see someone smile because he probably knows the answer. No? Okay.
If you want to test it, you need an interface?
Yeah, exactly. So, Well, here we can see the correct package where we neatly define an interface, and that interface is implemented by the some client struct, which defines a send mail on the some client struct. Apart from that, we also define a mock, which is also a struct, and that extends the testify mock struct. So this struct as well implements the interface because a send mail function is defined, which takes the same parameters and returns the same parameter. However, we can see here that we tell the testify mock that whenever a method on this struct is called, which is called send mail, we get 2 parameters and we return a error argument. Okay, so now we have our email package, and I defined a fake API here, which is just a struct with a sign-in API call. It extracts some basic out, for example, and when some IP is not equal to 0.0.0, it sends an email to the user. All right, so now we want to test this, and as we can see here, normally you would initialize the API with the normal email client. However, in our test case, we can do the following. So in our, you can also see this test suite is extending the base suite we just saw. We define some properties for some convenience. And then we built a default request, which we can throw in our sign-in API call function, for which we don't expect an error. And then we initialize our mocked client. So for this mocked client, we want to determine the behavior. So here we are saying that when the email client send mail function is called with whatever parameter we don't care about, it returns nil, so it doesn't return an error. So all we have to do now when we want to test our sign-in API call is call the function with the default request. However, we also want to know what happens when our email client, for example, returns an error. So we want to control this behavior a little bit more. So what we do in our test case is we create a new mock, and now instead of saying we don't care about the input here, we say that when the email address in the send mail function is error at weave.nl, we return an error stating that the function is unable to send an email. But when we receive wim at weave.nl, we still don't return an error. So in this default request, in the basic out, my email with weave is hidden. So we still don't expect an error from this function when the function is called with that parameter. However, when we define a new request with the error at weave.nl email address hidden inside it, we actually do expect an error, since we defined here that when our email client sends or returns an error, we actually return that error from this function. So now we actually defined the behavior of our sub-package, the email client, using mocking. We can even go a little further. So it might be that we not only want to determine the behavior of our external package, but we also want to verify that our function is calling that package with the correct arguments. So what we can do, we create a new mock. We don't care about the inputs anymore. It doesn't return an error, but this returns a mock.call struct, and on that struct, the run function can be called, which takes a func with the mock arguments, as a parameter, and we can extract those parameters from that args parameter. So we know both of those arguments were strings, and we can safely check, or safely typecast, and then check that the email address with which it's called is wim@we.nl, and yeah, we also verify the message. When it gets even more complicated is when, for example, our API call to the external package is asynchronously. So, for example, when we don't have an email function but a PDF service, for example, might take 1 or 2 seconds. So we don't want our function call to wait for that and just let it run asynchronously. However, when we would test that and we want to assert that that function is actually called, the test calls the function executes, go routine starts, function returns, test case terminates, and the go routine goes somewhere into the void, and we can't reach it. But we can also solve that with mocks by adding a wait group and just saying that before we call the sign in API call, we add 1 to the wait group, and when the mock call is executed asynchronously, we say done, and then the wait should continue here, and we can assert that the send email function on the email client is called once. Alright. So, I've got a really cool slide, so I need to show that. Yeah, alright. So now we have defined some test cases, but how good are those test cases? We want to analyze that in some way. We use makefiles in most of our projects. So here make_test executes all tests in this repository. Outputs, as you can see here, it outputs the results of the different packages. Here we can see some parameters. For example, the -p indicates on how many threads or how many test cases can run in parallel, and the cover profile creates a report, in this case reports, a folder where some statistics about our tests are generated. So the first thing we can check is the font coverage. So it's a little small screen. All right. So here we can see for every package and the coverage for every function. So for example, we were talking about our sign in API call. You can see that it's covered for 90.9% of the branches. But we can go a little further. I forgot the make command. Coverage report. Cool. Alright, and what this does is it renders a HTML file in your browser, and here you can really check which branches are covered and which are not. So this is actually the API call. So here we can see we just saw 90.9% is covered, and here we can actually see what point of our function hasn't been covered. So we didn't give an input of an incorrect basic out header, because in that case the request of basic out would probably not give an OK boolean, and then this error would have been returned. So this is a really cool way to analyze what stuff can I add to increase my coverage on my tests. Loading. Alright, so I've added some URLs. So the first two are for the test file library in the mocking documentation of Testify. And the third is the repository which we just looked at. I published it on our Weave GitHub repo, so when you want to play around with it, you can take a look there. I also added some tests for executing tests on database, on a Postgres database, and some examples on how you can execute your tests in parallel. So, to conclude, for everyone who is interested, we are last year we were the fastest growing software company in the Netherlands. We are always looking for new developers. So when you're interested in developing in Go, on Kubernetes, using Istio Docker, or you're just interested in building very cool front ends using web components, TypeScript, send an email to join@Weave, and let's drink coffee or beer. So thanks for listening.